Hello everyone and welcome to another AP Computer Science video. This video is going to cover the ability to read from a file on your computer system in your hard drive or wherever you keep your data to read content and use it in some fashion. So we've seen a scanner to read from data from a user through a console, so they can type it in and the program will pause and wait. But another possibility, and a much more realistic possibility for most programs, is reading data from some file location. When you open up an image in an image editor, it's reading the image and interpreting what it means and maybe visualizing it. When you open up a Word document, the word processing software will open up and interpret the content within it, whatever it might be, and display it however it needs to be, whether it's colors or fonts or any of that information. And so what we're going to do is we're going to work with simple files, just text files with strings and numbers and characters, but the ideas can be generalized to any data type. As long as we understand how to read the data, we can do that. And with ours, the data will be text content, and the scanner will be able to handle it without much effort. So there is a little bit of setup we're going to have to make, but it should be easy to do. First thing, I'm going to make a new package just to keep this example separate. So I'll make a new package, and we'll call it file stuff. And then we'll make a new Java class, and we'll call it file read example. Name is not important. Its idea is that we're just going to have a main that tests it. Now, what's going to happen is that there are some more technical details that we would, if we were planning a more robust program, that we might want to put some effort into, particularly with handling the fact that errors might occur. For example, the file gets corrupted or edited or deleted or is missing. But instead, we're going to kind of cheat our way through it, skip this idea because it's not important to what we're trying to actually do. And so we're going to just kind of make it easier for ourselves. And the assumption we're going to make is that if we're looking for a file, it does in fact exist. Now in a real system, you wouldn't want to do that, right? You don't want to make assumptions about where data is. You might want to ask the user for where the data is, or have them select it or type it in. But in this case, we're going to say, well, if we ask for a file, we're going to assume that it's in the location that we make it. So let's go ahead and make our main. And what I'll say is this should be an easy example, because the reality is reading from a file is the same exact idea as reading from the input from the console. The only difference we make, or really there is that we can assume that all the content is already available to us and we're going to read it line by line. We're not going to have to wait for anyone to run it. And the reality is if someone typed fast enough content or put all the content at once, then it would be basically the same idea. A scanner would behave the same way. So before we can have this, let's make a file that we're going to read. So let's do some examples. I will go ahead and so now here's where we're going to do things a little bit different. On the left side, where we normally deal with our projects, we see the little Java cups where our this is like the program view of our Java programs. There's a second tab called Files. And if you don't see this, we can always go to the Window menu and go to the Files or Control-2 shortcut. But there it is. It's the same content, but the view is a little bit different. So here's my notes here, and you can see that the folders that are here, they're visible a little bit different. Here it says source packages. Here we have an SRC folder, and then there's our packages, and there it is. But what matters for us here is that when we switch this view, the top level folder of our project, that's where we need to put our content to read it, because we're not going to worry about file paths and where the files are located. We're going to save ourselves the effort and just put them in the NetBeans project directly, and that way it's very easy to manipulate them. And so when you do your project for instruction cycle, the same idea will apply. To save yourself the effort of having to search for the file, you can simply put it in this one location and it will match up and fill. So here it is. I'm going to right click on our file folder, and I'm going to say a new file, and instead of picking one of these, I'm going to go to other. Instead of Java, I'm going to go to other at the bottom, and then on the file types, I'm going to go all the way to the bottom, empty file. And then I'm going to name the file, and here what we can do is we can name our file whatever we like, and really the extension is not important because we're going to interpret now. Typically text files are end in .txt extensions and things like that. There's assumptions about extensions, but for us the extension is arbitrary. You don't even have to put an extension if you don't want to, but I'll go ahead and put txt just so we know that it is a text file. So I'll say data.txt. And remember, the extension and the name is important, so we'll finish that. And there it is, and it's a blank file. So let's put some words below there. We'll put some numbers, 12, 45, 13. We'll go ahead and say something like complete sentence, and that's okay. And we can do as much as we like or as little as we like, and go from there. And I can put more. Today is another amazing day. There it is, right? So it doesn't really matter. And again, the extra line is there. We can get rid of it. It's just an extra space. I'm going to save it. It is saved as a TXT file, and there it is. Now, from the projects view, you won't see that file, but it is there, and we could always be sure. And notice in the hierarchy how it is within the folder, but not within the SRC or the build or any other content. It's in line with these two other files, right? It's stacked up in this one folder. That's important for us to place this. And again, the reason we're doing this is because when NetBeans looks for, if we don't put an absolute path, meaning from the top level of our computer directories, it might not find it. If we do it right like this, we can just put the name of the file and it'll know where the location is. So now we come back. So here we go. The first step, of course, is to make a scanner. We're going to read our file. So I'm going to go ahead and say scanner. And now I see, because I'm not reading from the keyboard, I'm not going to name it KB. Again, the naming is arbitrary. But I'm going to change the name to file reader. And it really doesn't matter, and maybe it's a little more wordy, but I'm happy with that. And let's make a new scanner. Now here's the thing. Normally we pass in a system.in, which represents the input stream of the console. Here we're going to do something a little bit different. And real quick, before we finish it off, we have to take an extra step. Because we're not reading from the system.in, we are reading from a file, we must construct a file object. Everything in Java, again, is class or object-oriented, class designed, and so files are things in our system, therefore they have a class description, so that means someone built a class called file. It has a constructor and methods and all kinds of wonderful things like that. We're not going to use much of it directly. We're going to use it through the scanner. But if we needed to know data about the file, for example, if I needed to know the location or content or whether I can read or write to it or things like that, then the file object would have that kind of data associated with it. So our type of variable is file. We'll call it data file, and the name is not important. And then we're going to construct a new file object. And the input is actually really easy. The input is the path to the file. So now what I'm going to do is I'm going to point out something. I'll open up my File Explorer. If I go to my Google Drive and I go to, well, let me start off from the top actually. I'll start with this PC. I'll go to my local disk, my users folder, my Google Drive folder, which is right here. And then I go to 2021, and then I go to, I believe I have my notes in, ooh, where do I have my notes? AP Computer Science, and there it is. Oh no, these are my class ones, so let me look where these are real quick. Let's do properties, because I don't remember where I have my content saved. Oh, it's in the F drive. Okay, F drive directly. Okay, so let's go back. So let's do this PC. Oh, yes, there it is, directly. There it is. And here we go. And then there it is, SRC. And then I can go to files, or actually, notice where it is. There's the data.txt file. And if I click on this address bar, there's my path. And the actual file of the path is the F drive and then the folder APCS notes and then slash the name of the file. So I'm going to copy this. I could put an absolute path. A path that could be complicated. So for example, if I wanted to go to, like I had mentioned, to the notes for another class of mine. So if I went to my, let me go back here. If I went to my notes here, and I can go to my SRC folder and find some particular file, we can see the path is more complicated. This is an absolute path from the top level to the file, or to the folder that contains the file. In our code, if the file is in this area, we don't need any of that stuff. We just name the name of the file. But if it's not, we either have to have some mechanism to find it, or we must put an absolute path to it. And so thankfully that we're very lucky, it's in the same location, so I can simply put the name of the path here. In this case, it's just going to be the name of the file, data.txt. So it does depend where your content is, and my suggestion for the projects is to do this same idea. Put it in the folder, because otherwise, if you use an absolute path and it works on your computer and you send me your code, my directory system might be different than yours, and therefore the absolute path, the reason it's absolute, means it cannot change. And so if you move the content, it's broken for someone else. There are relative paths as well, but we're not going to worry about that for now. This is a relative path. It's relative to where the program searches for it, which is right in this level. Notice there's some errors. We need to fix our imports. Let's do Control-Shift-I or right-click and fix imports. It'll tell us, oh, these are the two files. So now we've been using scanner, and now we're using the array list, which is Java IO file. Not array list, sorry, file. I don't know why I said array list. File, and then recognizes it. And then, of course, now the new is missing because we need our input. And so we used to do system.in, Now the input can also be a file object, so we can say data file. And so here's where they actually made multiple constructors. And now there's still an error, but it has nothing to do with the actual kind of recognition. If we read the error, it says, look, an unreported exception, file not found exception must be caught or declared to be thrown. So essentially what we're saying is the compiler recognizes that there is a danger in manipulating files on a directory system or in a computer system. The file might not be there. That's the first problem. Or it could be corrupt or locked or in some fashion blocked. So it says either you must handle this gracefully, or at least tell the compiler that you're accepting that the error will happen and let it happen. And don't try to stop it if it happens. And so that's what we're going to do to save ourselves the work. So now we're going to add something to the end of our main. So at the end of the main method, we're going to add this special keywords, throws, and then now is a special exception called file not found exception. And of course it doesn't recognize it, so we'll fix imports one more time. And that itself is also a class. So now there are 3 classes that we've never written, and we really only used one of them, file, file not found exception, and scanner. But now here it is complete. The computer recognizes that there may be errors that it can't fix, and it accepts it. We told it ignore them. They may happen, they may not, who cares? We create a connection to a file by using a path. It's a file object, and our scanner now can read from that file. All right, so we can say file objects connect to the file computer directory, whatever that happens to be. So I'm in Windows, it's in the Windows directory. If you're in a Mac or in a Linux, it's wherever your data is stored. So we'll also say, right, scanners can read from files similarly to reading from the console, right? So it's very similar to reading from the console. Now there is one limitation, and this is probably true of consoles if you think about it. You can't read data that's you've already passed. For the console, once they type it in, you either read it and use it, or it's gone. And so in a similar fashion, when you read a file, once you've read a line or a word or a piece of the file, you can't go backwards. You just got to keep going forward. So if you want to start at the beginning of the file again, you must restart. Now there are other file reading structures. Scanner is the most modern one, and it makes the assumption that you don't care to go back. And for our purposes, really, we don't need to, but theoretically, we could. So here it is. You cannot. So we'll say you cannot move backwards the file. Once content is read, it is no longer available unless the reading is begun again. Right, so you have to start at the beginning if you want to do that, which essentially means making a new scanner to the same file, and that's kind of a limitation. So now here's the question: how do we read from the file? And there are a lot of ways to do it, and I mean it really depends on the file type. But for our purposes, for text, the first attempt I'm going to make is simply to read every line and print each line to our console. So I'll read from the file and display it in the console. How do we know how many lines there are? This is the huge thing here, is that we don't know what content is in the file. It might be 1 line, it might be 10 lines, it might be 1,000,000 lines. So instead of saying read 1,000,000 lines because we don't know how many lines there are, we're going to instead ask a different kind of question. We're going to say, can you read 1 line at a time until there are no more lines to read? Right? So read 1 line at a time until there are no more lines available. And we're going to use a while loop. A while loop here, so it's funny because much of what we've done lends itself to for loops. This is a situation where a while loop does seem to naturally make sense, because it's kind of, we're basically saying while there are more lines to read a line. And that's convenient because that's what a while loop structure kind of does for us. And so here we go, our while loop, there's our body. Now the condition. In our scanner class, we've seen methods next int, next double, to retrieve string content, int content, double content, and so on. There's a few other ones. But there's also, along with each of those methods that retrieves content, there's also a question type method that returns, is there something else of this type available? So what we're going to say our scanner is called file reader, so we'll say file reader. And there's a method called has. So if you put the word in front of it, instead of saying next int, you can say has next int. Instead of has instead of next line, we can say has next line. So here's what we're writing. We're saying, and this is a method, so it does have parentheses, but this method has no inputs. So what we're saying is, while there is another line, so this returns a Boolean value. Is it true or is it false? Right? So we'll say scanner method as next line returns true if there another line to read in the file. Now, if there isn't, it returns false, which would make the loop stop, and therefore it would end. So we're saying while there is another line, is there another line, yes or no? And if so, then do the work. So what is the work we want to do? For this example, we're going to simply read the line. And since I said has next line, I'm going to use the next line. I don't have to because I don't know the structure of the line. This is another limitation. I don't know the format, or theoretically, if we're reading from a file, we as a designer of our program should know the format. So for example, if you work for Microsoft as a developer for the Office suite and you work on Microsoft Word, you should have a really good understanding of what a Microsoft a docx file, right, a Word file, looks like internally. So you should know how to parse through it and read the different pieces of it and how to interpret all the code or whatever it is behind the scenes and the text and display it. We either make assumptions about how the file is structured or only make assumptions about that there are lines and do what we got to do with it. So in this case, even though I know the first sentence or the first line is a single word and there are some numbers and there's another one, I don't want to make those assumptions, so I'm just going to read the line. So I'm going to say, you know what? Let's make a temporary string variable for whatever content it happens to be. We'll call it line, and then we'll call the method. We'll say file reader next line, and this is what we've done before. This is how we simply read it. Next line, when we used the console, would sit there and wait until they typed whatever they wanted and hit enter. So the assumption is still made. This will read everything in the file until a line break or \n character has occurred, until a new line character has occurred. Read file content until a new line character is found. And of course, sentences in a file, if we look at our file, that's going to read from the beginning to here. So we're going to get the first line. And you know what we can do? Let's also print out like what line number. So we'll say something like this. We'll say int line num, and we'll start off at 1. So we'll print out the line number and then the content and then go to the next line. So let's display it. So we'll say system.out. We'll print out the line number, so line num plus maybe a literal colon, and then whatever the content is, which in this case is line. So again, we know because we made the file, but if we were writing this code only, we don't know what's in there. What does the line have? Does it have words? Does it have numbers? Have, comma-separated values, decimal points? Who knows? But we read the entire line until a new line character. We printed out a line number, and then increase it, and then let's also bump up our line number. So go up by 1. And then when the program ends, the file is closed safely and ends for us. So let's try this out. I'm going to run our program. And there it is. The first line was hello there. The second line was some numbers. The third line, there it is. And the fourth line is there. And so the idea is that I read those things. And now if I add more, so let's leave a blank line just because, and then say, right, let's save it. Let's run this again. And let's just see how that's handled. And there it is, a blank line. Because is it really blank? And the answer is no. There's no text. In fact, there's one character on this line, the new line character. So the scanner does just what it did before. It kind of absorbs the new line, throws it out, but it's the delimiter, and then goes to the next line. And then it reads the content again. And then once there is no more, once there's nothing but beyond the cursor or where it's reading, that's when this becomes false and we can end. So now, if we made some assumptions, we could potentially do different things that are convenient. And so here's where I'm going to introduce another example. Let's make another data file. And so this, I think, is a nice feature. We'll say, let's make a new data file. So I'm going to do the same thing. I'm going to right-click on our folder. I'm in the Files view. I'm going to choose Other. I'm going to choose in my categories, the Other category at the bottom. In my file types, an empty file. And I'm going to call this, I don't know, totals.txt. So there it is, totals.txt. And it's a text file, so it's the same thing, but now let's do something like this. Let's do like 12, let's do comma separated numbers, 15, 17, 4, negative 3, 5, 4, 10, 10, 10, negative 4, 13, 5, 7, another. And let's do another one. And there it is. So notice something. We're not. This one has 4 characters or 4 numbers, comma separated. This one has 4. This one has 4. This one has 5. This one has 5. So we don't necessarily have control over how many characters there are, but that's fine. So now here we're gonna do something. We're gonna do something I think powerful. We'll say, okay, we're gonna read that. So let's do it again. This time we'll make another file object because we're not going to connect to this one. So we'll say file, and we'll call this one totals file is equal to a new file object. And again, I know where the file is. It's in the same location, so I can simply put the name. So totals.txt. And I'm gonna misspell it on purpose so we can see the exception that occurs. Scanner, and we'll call this one total reader is equal to a new scanner, and we're reading totals file. There we go. So our purpose is read the totals file, sum the values in each line, and store them in an array where each spot is a line. The spot is is a line. So in this example, we would say sum these and put this in the first spot in an array, sum these and put them in the second spot in the array, sum these and put them in the third spot in the array, and so on. So our array will have 5 positions, 5 spots, and each one should have the sum or an integer value of each of these. So let's go ahead and make that happen. Now again, we have to make some assumptions. The question is that we don't know how many lines there are. And I do because I counted it, so I could cheat and put 5, but instead we'll do this kind of the long way. So we're going to have to read the file twice, once to count how many lines there are, and then once to read the content. Unfortunately, right now, with an array, it's not possible to know how many lines there are ahead of time and to dynamically fill it in, so we have to kind of count the file. In the future, maybe we can solve that problem, but for now, we're going to have to accept it. So let's do this. First, let's prove that this fails. So I'm going to run it. The first content runs in fine, and then there it is. File not found exception. It says, look, totals.txt does not exist. It cannot find it. It fails, and then it breaks, and so it doesn't work. So what we did was we said, look, we know that error can happen, and normally the program would say, you can't even read a file unless you handle it gracefully. And we're not going to do that because it's not in the scope of the AP class to worry about those kind of fine details. Instead, we'll say, look, if we're using a file, let's make the assumption that that we know where it is. And so this allows us to make that happen. So let's fix this. Let's call it txt. So now let's read the line. So this is simple. We'll say line count is equal to 0. And we'll go through and we'll say while there are more lines to read, so total reader dot has next line. So while there's another line, simply bump up the line count. Notice I'm not looking at content. I'm just counting how many there are. At the end of this, I know how many there are, so we can make an array. And we'll call it sums. And how many spots are there? There are line count spots. And so in our example, I'm cheating, I'm saying 5, but it'll be line count. The idea would be, we don't know this number, but I mean, we technically do because we have counted that there are 5, but we expect to see 5. And we'll prove it. We'll go ahead and put a message, and we'll say something like found, and we'll put the variable line count lines, and there it is. So let's run it and let's see what it looks like so far. There's the first file. Ooh, it got stuck. Of course, there is a huge problem. It's stuck here trying to read the file, and let's stop it. And the answer is, we increase the line count, but the scanner does not actually move through the file unless you call one of the next commands. And so since I don't really care about the content, I'm just going to call next line. So I'll say total reader dot next line. And I'm not going to do anything with it. It's just going to, whatever, who cares. And then we'll run it again. And now notice how it goes. It has found 5 lines. Oops, I need a space right there. So let's do this one last proof. Let's do something like 777. Okay, there it is. And now let's run it one last time. Now there's 6 lines. So it reads the number of lines, and now we want to redo it. And again, unfortunately, the scanner does not allow us to go backwards, so we need to reconnect to the file, the same file, and we can even reuse the variables. So let's do that. Now we'll say, so let's just clean this up. We'll say, okay, count the number of lines disregarding content. We don't care about the content. And then we'll say, create an array for the sums with the correct number of spaces, right? So we know that there are line count spaces, and now we're gonna do the same thing. So let's reuse those variables. Instead of making another file, another scanner, we will simply, file doesn't have to be touched. Total's file is perfect. We'll just reuse total scanner. We'll say total scanner, total reader is a new scanner of totals file. So notice something, I did not put a data type because it's the same variable, so I'm just reassigning it to a new scanner object on the same thing. And now that I've done this, I can do the exact same work. So I'm going to say, and now we're going to say read content and sum the values, then and store the sum in the array. So we need to know which spot we are in the array. Total reader is, line count is how many there were. So now let's reset it. We can reuse it. So we'll say line count is equal to 0. Line count is now the next spot in the array to fill. And same thing as before, while. And so now here's what's nice. Well, since we know the length of this array, we don't have to use a while loop. We could technically do a for loop and say loop 4 times, or line count times, or not line count, but sums.length times, because we have how many lines there were. So theoretically, we don't have to say, are there more lines? We can just say, I know there are 6 lines, read them. But it doesn't matter. We'll stick with the same style, and we'll say total reader dot has next line. So while there are more lines to read, we'll read the line. Now here's the problem. So I could do next int, but if I do next int, I don't know how many there are. I can't assume how many characters. So we're going to do something a little more interesting, and we'll use this to our advantage. We'll say string line is equal to the next line. So we'll say total reader next line. That is an entire string separated by commas. Now, what's nice, and here's a feature, and this is not in the AP exam, but it's definitely a good method to know, and so you could use it in the AP exam if you think it'd help, is there is a string method called split, where you can tell it to take a string and split it into an array of strings, automatically based on a particular symbol. In this case, a comma or dashes or whatever you think is appropriate, spaces. And so here we're going to try this. We're going to say string array content. Actually, let's call it numbers. And so we don't know how it is. What's nice is we can say line dot split, and let's say we're splitting by commas. So we're saying, look, we know the structure of our file. There are comma separated numbers. So we're saying, you know what? Split by a comma, and then the array will contain things. They're still a string, so we can't do math with them yet, but now we have an array of strings. We can convert to strings. We've seen the integer and double classes have special methods called value of, and we can use that to convert. So let's do it. We'll say for int I equal to 0, I less than numbers.length, I plus plus. Now again, I don't know how many numbers there are in a line. It might be 3, it might be 10, it might be 1 or 0. The idea is that this will automatically loop however many it needs to be. There is no assumption about any of the data so far. The only assumption we make is that they're comma separated, which I think is a perfectly reasonable assumption. If you're going to have a program that reads a file, we should know the format. So we can say int num is equal to integer, and we are making the assumption that they are integers, so value of the ith character, so numbers at I. There's our conversion. And then now we can say our original array that contains the sums, so we can say sums at I plus equals the current content, which is num. And then there's our thing, and then that's our summation. So for every line, so while there are more lines, read a single line, split the line up into separated numbers as strings, go through each of them, convert them to an integer value, and sum them to the total. At the end of this loop, we've read the entire file, we've read every number from each line and added them to each other, and then gone to the next one. So I doesn't change. Well, we have to fix some things. So this is wrong. So this I should not be here, because this I is which character we're on. In this one, we should be doing it at line count. And then when we're done with this line, we can say line count plus plus, right? The I is only to get here, so that's the difference. So this has to be corrected to line count. So whatever spot we're in, and then it'll go up by each time. So let's see if this is correct. We need to print out everything in our array. We can use an enhanced for loop. So this is kind of a nice blend of everything we've seen so far. So let's say for each number in, we'll call S, in sums, print out the message sum and attach S. So there it is. So let's see what this looks like. And again, remember, this is an enhanced for loop or a for each loop. It says for every integer in sums, temporarily put it in S and then do something with that content. And I didn't put the curly braces because it's only one line. So let's see if this is correct. We run it. There it is. The sum is 48 of the first line. Let's make sure that's correct. 12 plus 15 is 27, plus 17 is 44, plus 4 is 48. That looked like it was correct. Right? 16 is the next one. Negative 3 plus 5 is 2, plus 4 is 6, plus 10 is 16. It looks like it's working. Let's do one more. 7, 7, and 7 is 21. So there it is. So this is a complex process. Now, again, did we make assumptions? Yes, but the assumptions we made are reasonable within the scope of design. If we're going to read a file, we must know what's in the file. That's the only real assumption we made, that each line is comma-separated numbers, a list of numbers. And in our case, we made assumptions that they're ints. We could have easily avoided that by doing everything with doubles. We could have said next double. Or we could have said double dot value of. And then even if they were whole numbers, it would have still worked. Now, yeah, this will break if I make this 7.0. But if I convert to, if I do double dot value of, and my array is of doubles, there would be no issues. So we're allowed to make assumptions about data because, again, as a designer, if you're reading in files, you have to make assumptions about those files. And for example, in the instruction cycle project, one file type will have lines that have ones and zeros in them. So you can make the assumption that it's only containing ones and zeros and use that to your advantage. So I hope you can see that the process of reading from a file is not particularly difficult. The connection is the same as if you do system.in, except the extra step that we have to connect to a particular file. NetBeans makes it easy as long as you put it in the same area within the folder. And just so we can see it again one last time, if I go to my Google Drive, I gotta go to my F drive, and I go to the notes, it's at the same level. There it is, data and totals.txt. Those two files are literally in the same folder as your project. So if your project is called instruction cycle, whatever, and you go to the folder, you will find it with those things. You can put the binary files that I'll give you as examples in this thing, right? So it's pretty convenient to be able to work with. So I'll see you in the next video. If you have questions, please feel free to reach out. I think that with this, we're moving forward in a very quick pace, and we have a lot of power now. We can read from files and do all kinds of things. Our programs are no longer tied to human input. Someone can generate a file ahead of time, or a computer can generate a file ahead of time, and simply our program can read it and do whatever we need to do. So I'll see you all in the next video.